Now, the success of human race is because of the ability to communicate and share information. Now, that is where the concept of language comes in. However, many such standards came up, resulting in many such language, with each language having its own set of basic shapes called alphabets. And the combination of alphabets resulted in words, and the combination of these words arranged meaningfully resulted in the formation of a sentence. Now, each language has a set of rules that is used while developing these sentences, and these set of rules are also known as grammar. Now, coming to today's world, that is the 21st century, according to the industry estimates, only 21% of the available data is present in the structured format. Data is being generated as we speak, as we tweet, as we send messages on WhatsApp, Facebook, Instagram, or through text messages. And the majority of this data exists in the textual form, which is highly unstructured in nature. Now, in order to produce significant and actionable insights from the text data, it is important to get acquainted with the techniques of text analysis. So let's understand what is text analysis or text mining. Now, it is the process of deriving meaningful information from natural language text, and text mining usually involves the process of structuring the input text, deriving patterns within the structured data, and finally evaluating the interpreted output. Compared with the kind of data stored in database, text is unstructured, amorphous, and difficult to deal with algorithmically. Nevertheless, in the modern culture, text is the most common vehicle for the former exchange of information. Now, as text mining refers to the process of deriving high quality information from text, the overall goal here is to turn the text into data for analysis. And this is done by the application of NLP or natural language processing. So let's understand what is natural language processing. So NLP refers to the artificial intelligence method of communicating with an intelligent system using natural language. By utilizing NLP and its components, one can organize the massive chunks of textual data, perform numerous automated tasks, and solve a wide range of problems such as automatic summarization, machine translation, named entity recognition, speech recognition, and topic segmentation. So let's understand the basic structure of an NLP application. Considering the chatbot here as an example, we can see first we have the NLP layer, which is connected to the knowledge base and the data storage. Now, the knowledge base is where we have the source content. That is, we have all the chat logs, which contain a large history of all the chats which are used to train the particular algorithm. And again, we have the data storage where we have the interaction history and the analytics of that interaction, which in turn helps the NLP layer to generate the meaningful output. So now if we have a look at the various applications of NLP, first of all, we have sentimental analysis. Now this is a field where NLP is used heavily. We have speech recognition. Now here we are also talking about the voice assistants like Google Assistant, Cortana, and the Siri. Now next we have the implementation of chatbot as I discussed earlier just now. Now you might have used the customer care chat services of any app. It also uses NLP to process the data entered and provide the response based on the input. Now, machine translation is also another use case of natural language processing. Now, considering the most common example here would be the Google Translate. It uses NLP and translates the data from one language to another, and that too in real time. Now, other applications of NLP include spell checking. Then we have the keyword search, which is also a big field where NLP is used. Extracting information from any particular website or any particular document is also a use case of NLP. And one of the coolest application of NLP is advertisement matching. Now here, what we mean is basically recommendation of the ads based on your history. Now, NLP is divided into two major components, that is the natural language understanding, which is also known as NLU, and we have the natural language generation, which is also known as NLG. The understanding involves tasks like mapping the given input into natural language into useful representations, analyzing different aspects of the language, whereas natural language generation, it is the process of producing the meaningful phrases and sentences in the form of natural language. It involves text planning, sentence planning, and text realization. Now, NLU is usually considered harder than NLG. Now, you might be thinking that even a small child can understand a language. So let's see what are the difficulties a machine faces while understanding any particular languages. Now, understanding a new language is very hard. Taking our English into consideration, there are a lot of ambiguity and that too in different levels. We have lexical ambiguity, syntactical ambiguity, and referential ambiguity. So lexical ambiguity is the presence of two or more possible meanings within a single word. It is also sometimes referred to as semantic ambiguity. For example, let's consider these sentences and let's focus on the italicized word. She is looking for a match. So what do you infer by the word match? Is it that she's looking for a partner? Or is it that she's looking for a match, be it a cricket match or a rugby match? Now, the second sentence here we have the fisherman went to the bank. Is it the bank where we go to collect our checks and money, or is it the river bank we are talking about here? Sometimes it is obvious that we are talking about the river bank, but it might be true that he's actually going to a bank to withdraw some money. You never know. Now, coming to the second type of ambiguity, which is the syntactical ambiguity. In English grammar, this syntactical ambiguity is the presence of two or more possible meanings within a single sentence or a sequence of words. It is also called as structural ambiguity or grammatical ambiguity. Taking these sentences into consideration, we can clearly see what are the ambiguities faced. The chicken is ready to eat. So here, what do you infer? Is the chicken ready to eat his food, or is the chicken ready for us to eat? Similarly, we have the sentence like visiting relatives can be boring. Are the relatives boring? Or when we are visiting the relative, it is very boring. You never know. Coming to the final ambiguity, which is the referential ambiguity. Now, this ambiguity arises when we are referring to something using pronouns. The boy told his father the theft. He was very upset. Now, I'm leaving this up to you. You tell me, what does he stand for here? Who is he? Is it the boy? Is it the father? Or is it the thief? So coming back to NLP, firstly we need to install the NLTK library, that is the Natural Language Toolkit. It is the leading platform for building Python programs to work with human language data, and it also provides easy to use interfaces to over 15 corpora and lexical resources. We can use it to perform functions like classification, tokenization, stemming, tagging, and much more. Now, once you install the NLTK library, you will see an NLTK downloader. It is a pop-up window which will come up, and in that you have to select the all option and press the download button. It will download all the required files, the corpora, the models, and all the different packages which are available in the NLTK. Now, when we process text, there are a few terminologies that we need to understand. Now, the first one is tokenization. So tokenization is a process of breaking strings into tokens, which in turn are small structures or units that can be used for tokenization. Now, tokenization involves three steps, which is breaking a complex sentence into words, understanding the importance of each word with respect to the sentence, and finally produce a structural description on an input sentence. So if we have a look at the example here, considering this sentence, tokenization is the first step in NLP. Now, when we divide it into tokens, as you can see here, we have 1, 2, 3, 4, 5, 6, and 7 tokens here. Now, NLTK also allows you to tokenize phrases containing more than one word. So let's go ahead and see how we can implement tokenization using NLTK. So here I'm using Jupyter Notebook to execute all my practicals and demo. You are free to use any sort of IDE which is supported by Python. It's your choice. So let me create a new notebook here. Let me rename as text mining and NLP. So first of all, let us import all the necessary libraries here. We are importing the OS, NLTK, and the NLTK corpus. So as you can see here, we have various files which represent different types of words, different types of functions. We have samples of Twitter. We have different sentimental WordNet, we have product reviews, we have movie reviews, we have non-breaking prefixes, and many more files here. Now, let's have a look at the Gutenberg file here and see what are all the fields which are present in the Gutenberg file. So as you can see here, inside this, we have all the different types of text files. We have Austen Emma, we have the Shakespeare, we have the Hamlet, we have Moby Dicks, we have the Carol Alice, and many more. Now, this is just one file we are talking about, and NLTK provides a lot of files. So let's consider a document of type string and understand the significance of its tokens. So if we have a look at the elements of the Hamlet, you can see it starts from the tragedy of Hamlet by William Shakespeare. So if we have a look at the first 500 elements of this particular text file, So as I was saying, The Tragedy of Hamlet by William Shakespeare, 1599, Actus Primus. We can use a lot of these files for analysis and text for understanding and analysis purposes. And this is where NLTK comes into picture, and it helps a lot of programmers to learn about the different features and the different application of language processing. So here I have created a paragraph on artificial intelligence. So let me just execute it. Now this AI is of the string type, so it will be easier for us to tokenize it. Nonetheless, any of the files can be used to tokenize. For simplicity here, I'm taking a string file. The next what we are going to do is import the word underscore tokenize under the NLTK tokenize library. Now this will help us to tokenize all the words. Now we'll run the word underscore tokenize function over the paragraph and assign it a name. So here I'm considering AI underscore tokens, and I'm using the word underscore tokenize function on it. Let's see what's the output of this AI underscore tokens. So as you can see here, it has divided all the input which was provided here into the tokens. Now let's have a look at the number of tokens here we have here. So in total, we have 273 tokens. Now these tokens are a list of words and the special characters which are separated items of the list. Now in order to find the frequency of the distinct elements here in the given AI paragraph, we are going to import the frequency distinct function, which falls under NLTK.probability. So let's create a fdist in which we have the function here, frequentDist. And basically what we are doing here is finding the word count of all the words in the paragraph. So as you can see here, we have comma 30 times, we have full stop 9 times, and we have accomplished 1, according 1, and so on. We have computer 5 times. Now here we are also converting the tokens into lowercase so as to avoid the probability of considering a word with uppercase and lowercase as different. Now suppose we were to select the top 10 tokens with the highest frequency. So here you can see that we have comma 30 times, the 13 times, off 12 times, and 12 times. Whereas the meaningful words which are intelligence, which is 6 times, and intelligence 6 times. Now there is another type of tokenizer which is the blank tokenizer. Now let's use the blank tokenizer over the same string to tokenize the paragraph with respect to the blank string. Now the output here is 9. Now this 9 indicates how many paragraphs we have and what all paragraphs are separated by a new line. Although it might seem like a one paragraph, it is not. The original structure of the data remains intact. Now another important key term in tokenizations are bigrams, digrams, and n-grams. Now what does this mean? Now bigrams refers to tokens of 2 consecutive words known as a bigram. Similarly, tokens of 3 consecutive written words are known as trigram, and similarly we have n-grams for the n consecutive written words. So let's go ahead and execute some demo based on bigrams, digrams, and n-grams. So first of all, what we need to do is import bigrams, trigrams, and n-grams from nltk.util. Now let's take a string here on which we'll use these functions. So taking this string into consideration, the best and the most beautiful thing in the world cannot be seen or even touched. They must be felt with the heart. So first what we are going to do is split the above sentence or the string into tokens. So for that we are going to use the word underscore tokenize. So as you can see here, we have the tokens. Now let us now create the bigram of the list containing tokens. So for that, we are going to use the nltk.bigrams and pass all the tokens. And since it is a list, we are going to use the list function. So as you can see under output, we have the best, and most beautiful thing in the world. So as you can see, the tokens are in the form of 2 words. It's in a pair form. Similarly, if we want to do the trigrams and find out the trigrams, what we need to do is just remove the bigrams and use the trigrams. So as you can see, we have tokens in the form of 3 words. And if you want to use the n-grams, let me show you how it's done. So for n-grams, what we need to do is define a particular number here. So instead of n, I'm going to use, let's say 4. So as you can see, we have the output in the form of 4 tokens. Now once we have the tokens, we need to make some changes to the tokens. So for that, we have stemming. Now, stemming usually refers to normalizing words into its base form or the root form. So if we have a look at the words here, we have affectation, affects, affections, affected, affection, and affecting. So as you might have guessed, the root word here is affect. So one thing to keep in mind here is that the result may not be the root word always. Stemming algorithm works by cutting off the end or the beginning of the word, taking into account a list of common prefixes and suffixes that can be found in an inflected word. Now, this indiscriminate cutting can be successful in some occasions, but not always. And this is why we affirm that this approach presents some limitations. So let's go ahead and see how we can perform stemming on a particular given data set. Now, there are quite a few types of stem. So starting with the Potter stem, we need to import it from nltk.stem. Let's get the output of the word having and see what is the stemming of this word. So as you can see, we have as the output. Now here we have defined words to stem, which are give, giving, given, and gave. So let's use the Potter stemmer and see what is the output of this particular stemming. So as you can see, it has given give, given, give, and gave. Now we can see that the stemmer removed only the ing and replaced it with an e. Now let's try to do it the same with another stemmer called the Lancaster stemmer. You can see the stemmer stemmed all the words. As a result of it, you can conclude that the Lancaster stemmer is more aggressive than the Potter stemmer. Now, the use of each of these stemmers depend on the type of task that you want to perform. For example, if you want to check how many times the words GIV is used above, you can use the Lancaster stemmer. And for other purposes, you have the Potter stemmer as well. Now, there are a lot of stemmers. There is one snowball stemmer also present, where you need to specify the language which you are using and then use the snowball stemmer. Now, as we discussed that stemming algorithm works by cutting off the end or the beginning of the word. On the other hand, lemmatization takes into consideration the morphological analysis of the word. Now, in order to do so, it is necessary to have a detailed dictionary which the algorithm can look into to link the form back to its lemma. Now, lemmatization, what it does is groups together different inflected forms of a word, which are called lemma. It is somehow similar to stemming as it maps several words into a common root. Now, one of the most important thing here to consider is that the output of lemmatization is a proper word. Unlike stemming, in that case where we got the output as GIV, now GIV is not any word, it's just a stem. Now, for example, if a lemmatization should work on gone, going, and went, it all stems into go, because that is the root of all the three words here. So let's go ahead and see how lemmatization work on the given input data. Now for that, we are going to import the lemmatizer from NLTK. Now we're also importing the wordnet here. As I mentioned earlier, that lemmatization requires a detailed dictionary because the output of it is a root word, which is a particular given word. It's not just any random word, it is a proper word. So to find that proper word, it needs a dictionary. So here we are providing the wordnet dictionary and we are using the wordnet lemmatizer. So passing the word corpora into the wordnet lemmatizer. So can you guys tell me what is the output of this one? I'll leave this up to you guys. I won't execute this sentence. Let me remove this sentence here. You guys tell me in the comments below what will be the output of the lemmatization of the word corpora. And what will be the output of the stemming? You guys execute that and let me know in the comment section below. Now let's take these words into consideration in give, giving, given, and gave, and see what is the output of the lemmatization. So as you can see here, the lemmatizer has kept the words as it is, and this is because we haven't assigned any POS tags here, and hence it has assumed all the words as nouns. Now you might be wondering what are POS tags. Well, I'll tell you what are POS tags later in this video. So for just now, let's keep it as simple as that, is that POS tags usually tell us what exactly the given word is. Is it a noun, is it a verb, or is it different parts of speech? Basically, POS stands for parts of speech. Now, do you know that there are several words in the English language such as I, ate, for, above, below, which are very useful in the formation of sentence, and without it, the sentence won't make any sense. But these words do not provide any help in the natural language processing. And this list of words are also known as stop words. NLTK has its own list of stop words, and you can use the same by importing it from the NLTK.corpus. So the question arises, are they helpful or not? Yes, they are helpful in the creation of sentences, but they are not helpful in the processing of the language. So let's check the list of stop word in the NLTK. So from NLTK.corpus, we are importing the stop words. And if we specify what all stop words are there in the English language, let's see. So as you can see here, we have the list of all the stop words which are defined in the English language. And we have 179 total number of stop words. Now, as you can see here, we have these words which are few, more, most, other, some. Now, these words are very necessary in the formation of sentences. You cannot ignore these words. But for processing, these are not important at all. So if you remember, we had the top 10 tokens from that particular word, that is the AI paragraph I mentioned earlier, which was given as ftest underscore top 10. Let's take that into consideration and see. What you can see here is that except intelligent and intelligence, most of the words are either punctuation or stop words and hence can be removed. Now we'll use the compile from the RE module to create a string that matches any digit or special character, and then we'll see how we can remove the stop words. So if we have a look at the output of the post punctuation, you can see there are no stop words here in the particular given output. And if we have a look at the output of the length of the post punctuation, it's 233 compared to the 273, the length of the AI underscore tokens. Now this is very necessary in language processing as it removes all the unnecessary words which do not hold any much more meaning. Now coming to another important topic of natural language processing and text mining or text analysis is the parts of speech. Now generally speaking, the grammatical type of the word, which is the verb, noun, adjective, adverb, article, indicates how a word functions in the meaning as well as the grammatical within the sentence. Now, a word can have more than one part of speech based on the context in which it is used. For example, if we take the sentence into consideration, Google something on the internet. Now, here Google acts as a verb, although it is a proper noun. So as you can see here, we have so many types of POS tags and we have the descriptions of those various tags. So we have the coordinating conjunction CC, cardinal number CD. We have JJ as adjective, MD as modal. We have the proper noun singular, plural. We have verbs, different types of verbs. We have interjection, symbol. We have the Y pronoun and the Y adverb. Now we can use POS tags as a statistical NLP task. It distinguishes the sense of the word, which is very helpful in text realization, and it is easy to evaluate as in how many tags are correct. And you can also infer semantic information from the given text. So let's have a look at some of the examples of POS. So take the sentence, the dog killed the bat. So here, the is a determiner, dog is a noun, killed is a verb, and again, the bat are determiner and noun respectively. Now let's consider another sentence, the waiter cleared the plates from the table. So as you can see here, all the tokens here correspond to a particular type of tag, which is the parts of speech tag. It is very helpful in text realization. Now let's consider a string and check how NLTK performs POS tagging on it. So let's take the sentence, Timothy is a natural when it comes to drawing. First, we are going to tokenize it. And under NLTK only, we have the POS underscore tag option and we'll pass all the tokens here. So as you can see, we have Timothy as noun, is a verb, as a determiner, natural as an adjective, when as a verb, it as a preposition, comes as a verb, to as a to, and drawing as a verb again. So this is how you define the POS tags. The POS underscore tag function does all the work here. Now let's take another example here. John is eating a delicious cake. Now let's see what's the output of this one. Now here you can see that the tagger has tagged both the word is and eating as a verb because it has considered is eating as a single term. This is one of the few shortcomings of the POS taggers. One thing important to keep in mind. Now after POS taggings, there is another important topic which is the named entity recognition. So what does it mean? Now the process of detecting the named entities such as the person name, the location name, the company name, the organization, the quantities, and the monetary value is called the named entity recognition. Now, under named entity recognition, we have three types of identification here. We have the noun phrase identification. Now, this step deals with extracting all the noun phrases from a text using dependency parsing and parts of speech tagging. Then we have the phrase classification, this step classification. This is the classification step in which all the extracted noun phrases are classified into respective categories, which are the location, names, organization, and much more. And apart from this, one can curate the lookup tables and dictionaries by combining information from different sources. And finally, we have the entity disambiguation. Now, sometimes it is possible that the entities are misclassified. Hence, creating a validation layer on top of the result is very useful, and the use of knowledge graphs can be exploited for this purpose. Now, the popular knowledge graphs are Google Knowledge Graph, the IBM Watson, and Wikipedia. So let's take a sentence into consideration that the Google CEO Sundar Pichai introduced the new Pixel at Minnesota Roy Center event. So as you can see here, Google is an organization, Sundar Pichai is a person, Minnesota is a location, and the Roy Center event is also tagged as an organization. Now for using NER in Python, we'll have to import the NE underscore chunk from the NLTK module, which is present in Python. So let's consider our text data here and see how we can perform the NER using the NLTK library. So first we need to import the NE underscore chunk here. Let's consider the sentence here. We have the US president stays in the White House. So we need to do all these processes again. We need to tokenize the sentence first and then add the POS tags. And then if we use the any underscore chunk function and pass the list of tuples containing POS tags to it, let's see the output. So as you can see, the US here is recognized as an organization. And White House is clubbed together as a single entity and is recognized as a facility. Now this is only possible because of the POS tagging. Without the POS tagging, it would be very hard to detect the named entities of the given tokens. Now that we have understood what are named entity recognition, NERs, let's go ahead and understand one of the most important topic in NLP and text mining, which is the syntax. So what is a syntax? So in linguistics, syntax is the set of rules, principles, and the processes that govern the structure of a given sentence in a given language. The term syntax is also used to refer to the study of such principles and processes. So what we have here are certain rules as to what part of the sentence should come at what position. With these rules, one can create a syntax tree whenever there is a sentence input. Now, syntax tree in layman terms is basically a tree representation of the syntactic structure of the sentence of the strings. It is a way of representing the syntax of a programming language as a hierarchical tree structure. This structure is used for generating symbol tables for compilers and later code generation. The tree represents all the constructs in the language and their subsequent rules. So let's consider the statement, the cat sat on the mat. So as you can see here, the input is a sentence or a verb phrase, and it has been classified into noun phrase and the prepositional phrase. Again, the noun phrase is classified into article and noun. And again, we have the verb, which is sat. And finally, we have the preposition on, the article and the noun, which are the and mat. Now, in order to render syntax trees in our notebook, you need to install the Ghost script, which is a rendering engine. Now, this takes a lot of time, and let me show you from where you can download the Ghost script. Just type in download Ghost script and select the latest version here. So as you can see, we have two types of license here. We have the general public license and the commercial license. As creating syntax and following it is a very important part, it is also available for commercial license, and it is very useful. So I'm not going to go much deeper into what syntax tree is and how we can do that. So now that we have understood what are syntax trees, let's discuss the important concept with respect to analyzing the sentence structure, which is chunking. So chunking basically means picking up individual pieces of information and grouping them into bigger pieces. And these bigger pieces are also known as chunks. In the context of NLP and text mining, chunking means grouping of words or tokens into chunks. So let's have a look at the example here. So the sentence into consideration here is we caught the Black Panther. We is the preposition, caught is a verb, the determiner, black is an adjective, and panther is a noun. So what it has done is here, as you can see, is that pink, which is an adjective, panther, which is a noun, and the as a determiner are chunked together in the noun phrase. So let's go ahead and see how we can implement chunking using the NLTK. So let's take the sentence, the big cat ate little mouse who was after the fresh cheese. We'll use the POS tags here and also use the tokenizing function here. So as you can see here, we have the tokens and we have the POS tags. What we'll do now is create a grammar from a noun phrase and we'll mention the tags that we want in our chunk phrase within the curly braces. So that will be our grammar underscore NP. Now here we have created a regular expression matching string. Now we'll have to parse the chunk and hence we'll create a chunk parser and pass our noun phrase string to it. So as you can see, we have a certain error, and let me tell you why this error occurred. So this error occurred because we did not use the Go script and we do not form the syntactical tree. But in the final output, we have a tree structure here, which is not exactly in the visualization part, but it's there. So as you can see here, we have the NP noun phrase for the little mouse. Again, we have the noun phrase for fresh cheese also. Although fresh is an adjective and cheese is a noun, it has considered a noun phrase of these two words. So this is how you execute chunking in NLTK library. So by now we have learned almost all the important steps in text processing, and let's apply them all in building a machine learning classifier on the movie reviews from the NLTK corpora. So for that, first let me import all the libraries, which are the pandas, the NumPy library. Now these are the basic libraries needed in any machine learning algorithm. We are also importing the count vectorizer. I'll tell you why it is used later now. Let's just import it for now. So again, if we have a look at the different elements of the corpora, as we saw earlier in the beginning of our session, we have so many files in the given NLTK corpora. Now let's now access the movie reviews corpus under the NLTK corpora. As you can see here, we have the movie reviews. So for that, we are going to import the movie underscore reviews from the NLTK corpus. So if we have a look at the different categories of the movie reviews, we have two categories, which are the negative and the positive. So if we have a look at the positive, we can see we have so many text files here. Similarly, if we have a look at the negative, we have 1,000 negative files also here, which have the negative feedbacks. So let's take a particular positive one into consideration, which is the CV00295990. You can take any one of the files here, doesn't matter. Now the above tokenization, as you can see here, the file is already tokenized, but it is generally useful for us to do the tokenization, but the above tokenization has increased our work here. And in order to use the count vectorizer and the TF-IDF, we must pass the strings instead of the tokens. Now, in order to convert the strings into token, we can use the detokenizer within the NLTK, but that has some licensing issues as of now with the Conda environment. So instead of that, we can also use the join method to join all the tokens of the list into a single string. And that's what we are going to use here. So first we are going to create an empty list and append all the tokens within it. We have the review underscore list, that is an empty list. Now what we are going to do here is remove all the extra spaces, the commas from the list while appending it to the empty list and perform the same for the positive and the negative reviews. So this one we are doing it for the negative reviews, and then we'll do the same for the positive reviews as well. So if you have a look at the length of this negative review list, it's 1,000. And the moment we add the positive reviews also, I think the length should reach 2,000. So let me just define the positive reviews. Now execute the same for positive reviews. And then again, if we have a look at the length of the review list, it should be 2,000. That is good. Now let us now create the targets before creating the features for our classifiers. So while creating the targets, we are using the negative reviews. Here we are denoting it as 0. And for the positive reviews, we are converting it into 1. And also we will create an empty list and we'll add 1,000 zeros followed by 1,000 ones into the empty list. Now we'll create a panda series for the target list. Now the type of Y must result into a pandas series. So if we have a look at the output of the type of y, it is pandas.core.series. That is good. Now let's have a look at the first 5 entries of the series. So as you can see, it is 1000 zeros, which were followed by 1000 ones. So the first 5 inputs are all zeros. Now we can start creating features using the count vectorizer or the bag of words. For that, we need to import the count vectorizer. Now once we have initialized the vectorizer, now we need to fit it onto the rev list. Now let us now have a look at the dimensions of this particular vector. So as you can see, it's 2000 by 16,228. Now we are going to create a list with the names of all the features by typing the vectorizer name. So as you can see here, we have our list. Now what we'll do is we'll create a pandas data frame by passing the SciPy CSR matrix as values and feature names as the column names. Now let us now check the dimension of this particular pandas data frame. So as you can see, it's the same dimension, 2000 by 16,228. Now if we have a look at the top 5 rows of the data frame, so as you can see here, we have 16,228 columns with 5 rows, and all the inputs are here 0. Now the data frame we are going to do is now split it into training and testing sets, and let us now examine the training and the test sets as well. So as you can see, the size here we have defined as 0.25. That is the test set, that is 25%. The training set will have the 75% of the particular data frame. So if we have a look at the shape of the X train, we have 15,000. And if we have a look at the dimension of X test, this is 5,000. So now our data is split now. We'll use the naive Bayes classifier for text classification over the training and testing sets. So now most of you guys might already be aware of what a naive Bayes classifier is. So it is basically a classification technique based on the Bayes theorem with an assumption of independence among predictors. In simple terms, a naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. To know more, you can watch our naive Bayes classifier video, the link to which is given in the description box below. If you want to pause at this moment of time and check quickly what a naive Bayes classifier does and how it works, you can check that video and come back here. Now to implement naive Bayes algorithm in Python, we'll use the following library and the functions. We are going to import the Gaussian NB from sklearn library, which is a scikit-learn. We are going to instantiate the classifier now and fit the classifier with the training features and the labels. We are also going to import the multinomial naive Bayes because we do not have only 2 features here, we have the multinomial features. So now we have passed the training and the test data set to this particular multinomial naive Bayes. And then we will use the predict function and pass the training features. Now let's have a look and check the accuracy of this particular matrix. So as you can see here, the accuracy here is 1, that is very highly unlikely, but since it has given 1, that means it is overfitting and it is overly accurate. And you can also check the confusion matrix for the same. For that, what you need to do is use the confusion underscore matrix on these variables, which is y underscore test and y underscore predicted. So as you can see here, although it has predicted 100% accuracy, the accuracy is 1. This is very highly unlikely, and you might have got a different output for this one. I've got the output here as 1.0. You might have got an output as 0.6, 0.7, or any number in between 0